sir. My name is Nikita. I am from EC branch. My subject is Information Theory and Coding Techniques, and my topic is Space-time modulation, principles and applications. Coming to introduction, the ever-increasing demand for high data rate wireless symbols has led to a crowded electromagnetic spectrum. This demand has successively spurred the development of versatile microwave and millimeter wave integrated components possessing high selectivity, multifunctionalities, and enhanced efficiency. These components require a class of non-reciprocal structures endowed with extra functionalities. Example: frequency generation, wave amplifications, and full duplex communications. Space-time modulation has been shown to be perfect candidate for high data transmission, gives it extraordinary capability for electromagnetic wave engineering. Space-time modulation media are dynamic and directional electromagnetic structures whose constitutes parameters vary in both space and time. Recently, space-time modulation media have received substantial attention in the scientific and engineering communities, which has some multifunctionalities and enhanced efficiency. And the space-time modulation are dynamic and directional electromagnetics, which they include some electromagnetic frequency generations, wave amplifiers, and full duplex communications. Where it has some space-time, it has some dynamic and directional electromagnetics, which vary in both space and time modulations. The unique and exotic properties of space-time modulation media have led to the development of original physics concept and novel devices in acoustics, microwave, terahertz, and optic areas. Space-time modulation media were went initially studied in the context of traveling wave parametric amplifiers in the 50s and 60s. In that era, magnetic based non-reciprocity was the dominant approach to the realization of isolators, circulators, and other non-reciprocal systems. However, magnetic based non-reciprocity is a plagued with bulkiness, non-integrability, heaviness, and incompatibility with high frequency techniques, which has some studies in the concepts of traveling wave parameters, and it has some isolators, circulators, and other non-reciprocal systems. We first present a global perspective on the principle of space-time modulation, natural and artificially created STM media and their applications in a communication system. Next, the interaction of artificial STM media with electromagnetic waves is analyzed, and numerical simulations of electromagnetic wave propagation and scattering from these media is provided. Next, the dispersion diagram of the STM medium is studied for the characterization of subluminal aluminum and the subluminal STM modulation. In addition, we investigate the effect of length, modulation velocity, modulation frequency, and the equilibrium on wave scattering from the space-time modulation medium. These applications include, but are not limited to, magnetic free isolators, magnetic free circulators, transceivers, front-end, and pure frequency mixers. It has some dispersion diagrams of space-time modulation medium, and it has some characterizations of subluminal, luminum, and superluminum space modulation. Principles of space-time modulation. First one is natural phenomena due to space-time modulation. Space and time represent general form of the existence of matters. Space possesses three dimensions, that is length, width, and height, whereas time is represented by one dimensional from the past throughout the present to the future, which is unrepeatable and irreversible. which is unpredictable and irreversible. Spacetime modulation leads to the various natural phenomena. For instance, consider a figure: the water wave in the ocean or unidirectional and possesses very long wavelength with the same small amplitude. However, flying an aeroplane on the top of the ocean along with the same direction as the water waves lead to space-time modulation of the water. These in turn yields tremendous amplifications of the water waves. The same phenomena occurs in the ocean when a strong wind blows along with the same path as the water waves and lead to huge water waves at the ocean surface. Second one is analysis of general periodic spacetime modulation media. In physics and engineering, spacetime modulation is created by spatiotemporal modulation of the constitutive parameters of media. Example includes electric permittivity, magnetic permeability, or electrical conductivity. Such spacetime modulation has been realized by a time-varying modulation signal that propagates along the medium and spatiotemporally modulates variable capacitance and inductance, which are added to the intrinsic capacitance and inductance of the background medium. A general spacetime modulation slab is depicted in figure, such as general ST modulation is represented by an unidirectional refractive index. Here are some principles of ST modulation and sinusoidally ST modulation, applications of ST modulation. Principles includes two. They are natural phenomena due to ST modulation, analysis of general periodic STM medium. And the sinusoidal STM medium includes five types: general sinusoidal ST modulation, subluminium or luminium and superluminium ST modulation, numerical simulations and parametric study, non-reciprocal scattering, superior performance of equilibrium ST modulation. And applications include four types: magnetic free linear isolator, magnetic free circulator, transceiver front end, pure frequency mixer. And the magnetic free linear isolator includes quasiotic isolator, asymmetric isolator, and self-based broadband isolator. And the transceiver front end includes broadband low pass, non-reciprocal component, transmitter, and full duplex transceiver. Applications of these include spacetime modulation is a technique used in wireless communication system that combines modulation and coding across multiple antennas and time slots. This approach leverages the spatial and temporal dimensions to enhance the performance of communication systems. Here are some key applications of spacetime modulation in information theory and coding. The first one includes the improved reliability and error performance. Spacetime modulation, particularly through techniques like spaced block codes and spacetime terrace codes, significantly enhance and reliability of wireless communication systems by transmitting multiple copies of the signal across different antennas and time slots. It introduces redundancy that helps in combating fading and interference, thereby reducing the error rates. Increased data rate. In increased data rate, spacetime modulation techniques enables higher data rates by effectively utilizing the multiple spatial channel created by multiple antennas. Techniques used as spatial multiplexing allows the transmission of different data streams simultaneously and enhanced diversity gains. Diversity techniques are essential in wireless communication to mitigate the effect of multipath fading. Spacetime modulation provides both spatial and temporal diversity, which improves the robustness of the communication system. Channel capacity optimization. Channel capacity optimization includes the contribute to optimize the channel capacity. Application in 5G and beyond. Spacetime modulation is a fundamental concept in the design of modern wireless standards such as 5G, where MIMO technology is extremely used to meet the high data rate. Conclusion. Space-time modulation structure represents an emerging class of dynamic and directional materials. ST modulation is a promising new paradigm for non-reciprocity and frequency generations, ranging from acoustic and radio frequencies to terahertz and optics, and is compatible with the higher frequencies techniques. This presents the global perspectives on the principles and applications of space-time modulations, which includes some space-time modulation media can be implemented in a conjunction with advanced space-time modulation systems. Thank you.